Yeah. Good evening, children. Good evening. Good evening, online students. Good evening. So, children, in today's session, as I was telling you here, you're going to first, so these are some important proofs or important questions from the chapter polynomials. All right. So I want you to work out by yourself, meaning you have the question and the answer. Go through the answer, understand as much as you can, work it out in your book, and then I'll explain. All right? Yeah. Get started. This is the first one. Take your time. There's no hurry. You first go through the answer, try to understand. Then you write down in your book. Yeah. Online students, I've shared my screen. It's visible, right?
Yes, yes.
Yeah. You got the instruction, all of you?
Yes,
ma'am. Yeah. Finished. Finished, all of you? Online students? Done working this? Okay. All right. So what's the numerator like? Oh, you're still writing? No, yeah, finish it, finish. All of you finished. Yeah. Sana? Lassie and Niveda? All right. So both the numerator and the denominator are of the form x cubed plus y cubed plus z cubed. Because you can see only 3 perfect cubes in the numerator and in the denominator, correct? You can see 3 perfect cubes. x cubed plus y cubed plus z cubed in the numerator, and a similar thing in the denominator, x cubed plus y cubed plus z cubed, or you can call it p cubed plus q cubed plus r cubed. So what is x cubed plus y cubed plus z cubed? If x plus y plus z is 0, then it is equal to 3xyz. If p plus q plus r is equal to 0, then it is equal to 3pqr. Okay, so p cubed plus q cubed plus r cubed is equal to 3pqr if p plus q plus r is 0. So you must first check if p plus q plus r is 0. If it is 0, then it is equal to 3 into p into q into r. So how do you check? We call the numerator xyz, right? Okay. Okay. So what is x in the numerator, children? X is equal to a square minus b square. What is y? And what is z? So when you add, what do you get? X plus y plus z? A square minus a square plus b square minus b square minus c square plus c square. 0. So x plus y plus z is 0. Then what is the numerator? 3 into x into y into z. So it will be, the numerator will be 3 into x, that is a square minus b square, into y, that is b square minus c square, into z, c square minus a square. So we factorize the numerator. So we factorize the numerator. Now the denominator. In the same way, denominator, what is p? What is p? A minus b. Online students, please participate. What is q? Online students, what is r? C minus a. C minus a. C minus a. Very good. C minus a. Now what is p plus q plus r? A minus a cancels, minus b plus b, minus c plus c. So 0. P plus q plus r is equal to 0. So the denominator is 3 into p into q into r. 3 into p. This is p into q into r. So we factorize the numerator and the denominator. Now 3 and 3 will get cancelled. Yeah, now we should further factorize the numerator. In the numerator, we have a squared minus b squared, which can be written as a plus b into a minus b. A plus b into a minus b. B square minus c square is b plus c into b minus c. C plus c into c minus a. Divided by very good. So a minus b cancels. B minus c, b minus c. C minus a, c minus c. So we are left with a plus b into b plus c into c plus c. That's all. Very simple. 4 marks. All right. Yeah. All right, children. Now I'm going to give you a similar question for which I don't have the answer, but you can do it. I don't have the answer for this one. We'll do it. I'll work it. Once you finish writing, I'll work it. And I'll try the similar. Very similar, right? Yeah, do this one, children. Anybody has not completed online, take a screenshot. If anybody not completed here? Not completed, yeah, complete. Anyone online has not completed this answer, please take a screenshot or a photo using a mobile phone. Blessy, it's difficult for you to read from there, Blessy. Is it difficult for you to read from there? Come to the first bench. Why do you always sit there? Okay, I'll allow the others to write down the next question. Then I'll show you this presentation. You can complete it, okay? Yeah. Online students, this is the next question. Don't mind the number. It's written question number 4. You write 2 in your book. It's not 4, it's 2. Yeah. Refer to the earlier working. Use the same style of, meaning use the same presentation. Like we did, I think A, B, C, and P, Q, R. Use the same steps. You can refer. You're practicing now, so you can refer. Taking the question, online students?
Yes, ma'am.
Yeah. Okay. Yeah, Blessy. Is it clear from here? Yeah, complete. Question, huh? Is this over? What's answer you got? No. Louder. 0. Anna? Okay. Mutsa. Doing. Okay. Niveda? Okay. Roshni? Very good. Twice? Same answer. Very good.
Yes, finished.
Very good. Yes, Pranav, what's your answer?
Plus 2x plus 3y into 3y plus 4z into 4z plus 2x.
4z plus
2x.
2x. Very good. Four z plus 2x. Very good. Okay, so the numerator again is numerator, denominator, same method, no? A cube plus B cube plus C cube, and denominator is P cube plus Q cube plus R cube. So what is A? Here. It's not easy to find out that. This one is no, less noise, children. You have been dropping since then. Naughty girl, I think you are. Huh? You've been dropping something or the other. Oh, I'll beat you. Don't talk. Yeah. Sit, one of you go behind. Sit behind. This is not a party house or a clubhouse. We have not met. We have not assembled here to share jokes and have fun. It's fun with math. Okay, not fun with jokes. Yeah, children. Yes, Sabarna. I'm so sorry, Sabarna. Sadhana. Okay, Sadhana. So see, Sadhana. This one is A, Sadhana. This one is A. Okay, this one is A cubed. See, this is only A. This is your A, and this is cube. Similarly, this is that B. This is B. This one is B, and this is that cube. This is C. This one is C, and this is C cube. So this is C. In the denominator, if you call it PQR, see, this is P cubed. Q cubed. R cubed. All right. So what should we first check? By the identity, what should we first check? If the numerator we say is A cube plus B cube plus C cube, you should check A plus B plus C, right? So what is A? Excuse me. 4x square. Now evaluate pannu. Yeah. 9y square. All right. What is B? Online students, B. C.
This 9 square minus 16 is a square.
And C.
16 is a square minus 4x square.
All right. A, B, C we have written because the numerator is like A cube plus B cube plus C cube. Now A plus B plus C, we're going to add A plus C. Presentation like this one you should present. I have already shown how to present it. I'm just roughly working it for you. You should exactly present it like this. Let A, whatever you see here. It should be exactly presented like this. This we are working roughly, but you will understand clearly. Yeah, no. Add. You should add, right? When you add, what happens? 4x square minus 4x square minus 9y square plus 9y square. 16z square minus 16z square. It becomes 0. So A plus B plus C is 0. Now we'll check the denominator also. Denominator, we're calling it P cubed plus Q cubed plus R cubed. So what is P? What is P? To cover the cube, that is only P. P cube is there. No, cover the 3. Cube. Cover the power 3. The remaining thing is P. So 2x minus 3y. Then Q. 3y minus 4z. And R. 4z minus 2x. Now find P plus Q plus R. So 0 again. You can see 2x minus 2x plus 3y minus 3y plus 4z minus 4z. 0. So now the numerator will become, what is the numerator now? A cube plus B cube plus C cube. But A plus B plus C is 0. So the numerator is equal to 3ABC. 3. See, ABC is here. A into B into C. So 3 into A is this one. This is A. This is A. into B. This one is B. You can see on the left side. This is B. Into C. What is C on the left side? This is C. And the denominator is 3ABC. So 3PQR. 3PQR you can see there. What is P? 2x minus 3y. Q. R. It's all there. Now 3 and 3 will get cancelled. Now the numerator should be written as 2x the whole square minus 3y the whole square. Because it's in the form a square minus b square. All right. Then this one has what's the next one? 3y the whole square minus 4z the whole square. Then the next one. Divided by the denominator as it is. Denominator as it is. Now a square minus b square. See, if you've done it like this, okay, 4x square minus 4x square minus 9y square. If you've taken that itself as a square minus b square, and if you've written 4x plus 9y into 4x minus 9y, that's wrong. Have you done that? Yeah, that's wrong. You should write it as something the whole square. The 2 should be for the whole. Whatever is in the base, the whole thing should be raised to the power 2. Here in 4x square, the square is only for x. It is not for 4. In 4x square, the power 2 is only for x. It is not for 4. It should be something the whole square minus something the whole square. Now in 9y square, the square is only for y. It is not for 9. After that, it is not a square minus b square. It should be a, the full thing should be squared, minus b, the whole of b should be squared. So it should write 4x square as 2x the whole square. What is 2x the whole square? 2x into 2x. 2x into 2x. 2 to the 4, x into x is x square, 4x square. What is 9? What is 9y square? 3y the whole square. What is 3y the whole square? 3y into 3y. 3y into 3y is 3y the whole square. 3y into 3y. So 9y square. You should write it as something the whole square. This one is not that. This one, and this one, they are not. They can be. You can write them as a square minus b square, but they don't. They are not already in the form a square minus b square. These three things, this one, and this one should be presented in the form a square minus b square. They are not already in that form. They are in a different form, but you can write it in the form a square minus b square. That already is not a square minus b square because the square is not for the full base. So now you should write it like this. You can expand and see what is 4z the whole square. 4z into 4z, 16z square. It should be in this form. Now a square minus b square is a plus b into a minus b. So a plus b into a minus b. Because what is it? This is a and this is square. So this is only a. This 2x is a and 3y is b. Then next one, continue. Continue. Louder, darling, please, louder. 3 plus 4z, very good. Very good. Next. 1 second. Yeah. No place. Okay, I think you can understand. 4z minus 2x. Yeah, divided by whatever you see there. Yeah. Now, so whatever is left is the answer. That you should write again. So the answer is 2x plus 3y into 3y plus 4z into 4z plus 2x. All right. I'll wait for some time. If you have not finished it correctly, do it now. Whatever correction you have to make. See, maybe your friend has worked it correctly, but you have not worked it correctly. You should write. Don't think if I'm writing and my friend is not writing, then teacher will think that I've gone wrong. It's okay if you've gone wrong. Now learn it correctly. Write. Please write if you have not worked it correctly, children. Online students, please check your steps. If you've gone wrong anywhere, please correct it. Deepthi, you're continuing the test?
Yes, ma'am.
Okay, good, good. You stay in the meeting till 8:15 and then whatever you finish till 8:15, stop there, take pictures of the remaining answers and share it on WhatsApp with me. All right?
Yes, ma'am, I will.
Yeah, yeah. Okay, yeah. Just let me know when you leave the call, okay?
Yes.
Yeah. One second. All right, children. Done, all of you? No, I'll do one thing. Just leave some space for that. I'll share the picture. You can complete it later at home. Leave some space for that. Yeah. Do this one. Take the question. I didn't notice them. But your business is fine. For 120, maybe 60, 30, 40, 70, 50, 10,
Actually, they told this as a PPL project based learning, and this one has the PPL is in one of the courses. They don't teach. I know my last just
If you want to control that,
I didn't finish the small almost I finished this in the I don't understand how.
yes, you can leave. To leave, bye.
Thank you.
Yes, you done. Yeah, okay. No? Okay. That's you. No, no. See, only we can't go back to that age, right? Only at that age you can be like that. Yeah, so it's really nice. Ah, funny. No, no. Maybe no. Elders will not see that as funny. Okay, okay. Plus, if you don't mind, can I just slide the door close? All right. So in this one, so in this one, x square minus 1 is a factor, children. Now, to use the remainder theorem, the divisor should be linear. Now, this divisor is quadratic, x square minus 1. The divisor is quadratic, x square minus 1. X square minus 1. The divisor is quadratic. The remainder theorem can be used only when the divisor is linear, not for quadratic. So if the divisor is quadratic, factorize it and get the linear factors. So x square minus 1 is like x square minus 1 square. A square minus b square, which is a plus b into a minus b. So the answer, why are we factorizing? The answer is this divisor x square minus 1 is quadratic because x square, it's quadratic. To use the remainder theorem, the divisor should be linear only. The power of x should be 1 only. Should not be anything more than 1. The dividend can be anything, any power. The divisor, the power of the divisor, that is the power of the x in the divisor, should be 1. It should be linear. So you factorize it. So the divisor is x square minus 1, which is like a square minus b square. Factorize it a plus b into a minus b. Now, supposing I tell you that, 300, okay. So 15, 300 is divisible by 15. 300 is divisible by 15. What are the factors of 15? 3 and 5, 3 into 5. So if 300 is divisible by 15, 300 is divisible by 3 and 300 is divisible by 5. If 300 is divisible by 15, then 300 is also divisible by the factors of 15. In the same way, if this one is divisible by, because it's a factor of, x square minus 1 is a factor of this one. Like 15 is a factor of 300. If 15 is a factor of 300, then 300 will be divisible by the factors of 15, right? So since x square minus 1 is a factor of this one, the factors of x square minus 1 are x plus 1 and x minus 1. So that means this one, this dividend, is divisible by x plus 1 and is also divisible by x minus 1. Because it's divisible by x square minus 1. This one is divisible by x square minus 1. So then it will also be divisible by its factors x minus 1 and x plus 1. So we'll call this one p of x. We'll call this p of x. What is given? X square minus 1 is a factor of p of x. X square minus 1 is a factor of p of x. But x square minus 1 is quadratic, so we have to break it down. So we get x plus 1 and x minus 1. So factor means p of x is divisible by x square minus 1. That's the meaning. P of x is divisible by x square minus 1. That means p of x is also divisible by x plus 1 and x minus 1. So now let's take them one by one. Let's take them one by one. So that's what it is, p of x. This one is a factor. So, but this can be factorized as this and this, which means x minus 1 and x plus 1 are factors of p of x. So now let's take the first case. X minus 1 is a factor of p of x. Let's take that first case. So equated to 0, x is equal to 1. So p of 1 will be 0 because it's a factor. So the remainder will be 0. If it's a factor, the remainder will be 0. P of 1 will be 0 because it's a factor. So how will you find that p of 1? Here in p of x, wherever there is x, you should use 1. And we have done that here. Is equal to 0. This is equal to 0. Is equal to 0. So when you work this, you get a plus b plus c plus d plus e is equal to 0. Now x plus 1 is a factor. So equated to 0, x is equal to minus 1. So that means p of minus 1 is 0. How will you work p of minus 1? In p of x, wherever there is x, use minus 1. So it will be a into minus 1, the whole power of 4, plus b into minus 1, the whole cube, plus c into minus 1, the whole square, plus d into minus 1, plus e is equal to 0. Now on simplifying this, be very careful. Minus 1 to the power 4 is plus 1. Because minus 1 into minus 1 into minus 1 into minus 1, plus 1. Minus 1, the whole cube is minus 1. Minus 1, the whole square is plus 1. Then this minus 1 plus c is equal to 0. So open up the brackets. And this is what we have. Now we need to show that a plus c plus e is equal to 0. We need to show two things. We need to show that a plus c plus e is equal to 0. And we should also show that b plus d is equal to 0. We need to prove these two things. A plus C plus E is equal to 0 and B plus D is also equal to 0. That's what is given like. See, supposing you have to get A is equal to 5 and B is equal to 5. That means you must prove that A is equal to B is equal to 5. If you have to get A is 5 and B also is 5. So that means you should show that A is equal to B is equal to 5. So here you have to show that A plus C plus E is equal to 0. You should also show that B plus D is equal to 0, which means you must show that A plus C plus E is equal to B plus D is equal to 0. So to get these two results, we'll add the two equations. We need to get two results. Now we have two equations, right? We'll add the two equations, you will get one result. Subtract the two equations, you will get the other result. So let's add the two equations. Adding means don't change the signs. Adding means do not change the signs in the second equation. Write the equations one below the other. In the second equation, don't change the signs. That means you're adding. If you change the signs, you're subtracting. So without changing the signs, I've written the equations one below the other. This gets cancelled. This gets cancelled. So 2A plus 2C plus 2E is equal to 0. You must cancel. See, I've told you while typing, I cannot cancel this like this. Or maybe it's possible, I don't know. Maybe, like, I don't know how to cancel it like that. Whatever. So I'm not able to cancel. This you should show in your book. So you must cancel it like this. So you get 2A plus 2C plus 2E is equal to 0. Now take out 2 common. So you'll get 2 of A plus C plus E is equal to 0. So when this 2 on the other side will come for division, 0 by 2. So A plus C plus E is equal to 0. So we proved the first result. Now subtract the two equations. So write the equations one, write the same two equations. This one and this one below the other, and change the signs in the second equation. So now my A plus A minus A gets cancelled. Now this is plus B plus B. Take the new sign. Take the new sign. See, again, I can type it only here. You show it here like this. Minus B. This is plus. This is minus. This is plus. This is minus. You can change the signs there. So A minus A. Plus B, 2B. C minus C cancels. Plus D, plus 2D. E minus C cancels is equal to 0. So 2 common, B plus D is equal to 0. 2 comes for division. So B plus D is equal to 0 by 2, which is 0. You don't have to show 0 by 2 and all that. You understand? B plus D is equal to 0 by 2, which is 0. So we proved that A plus C plus E is 0 and also B plus D is 0. That means A plus C plus E is equal to B plus D is equal to 0. So you must remember this answer like a story. There's nothing to practice in this. So first thing is the divisor x square minus 1 is quadratic. We cannot straight away use the remainder theorem. We have to factorize x square minus 1 and get the linear factors. So the linear.
Excuse me, ma'am.
Yeah, Deepthi?
Now I'm done.
Yeah, all right. Share the remaining pictures.
No, I thank you.
Okay, yeah, I got it. Yes. Okay, so with this, have you completed all the question papers I'd sent?
Yes, ma'am.
Yes.
Yes, ma'am. You sent
But I
nominal
don't.
numbers and whole numbers, and those both are completed.
1 second, but I don't. Where's it? Match the following at shared and whole numbers.
Ma'am, I have done all of them. Third and fourth question, both of them are set.
No, regarding the properties on whole numbers, I shared. Oh, you've written like this, is it? Okay, natural
Yes.
number. No. Oh, yeah. Okay, I think I can see it. Okay, fine, Deepthi. Yeah, thank you. Bye.
Bye.
Yeah. So x plus 1 and x minus 1 are the linear factors. Now take it one. So you'll get two cases because you have x plus 1 as a factor and x minus 1 as another factor. So you have two cases now. So case 1 is this one and case 2 is this one. So when you work this, you get one equation. When you work this one, you get another equation. Add the two equations to get one result. Subtract the two equations to get the other result. That's all. All right, children? Online students, any questions? Online students, any questions?
No, ma'am.
Okay. Yeah, do this one.
Miss,
Yes, Hari?
Miss, you can show the first question answer once I take a screenshot, Miss.
Yeah, sure, yeah.
Yes, Miss.
All right. Yeah. Somebody's mic is enabled. Disable your mic. Coordinate geometry and lines and angles. Finished. Okay. Oh, yeah. When is exam? What? When is exam? September. In September. Yeah, by August 10 we can finish coordinate geometry, linear equations, Euclid's geometry, and yeah, the next one is what? Coordinate geometry, then linear equations, Euclid's geometry. Lines and angles, maybe I can just start. You only said lines and angles. Linear. Completely. 3 pages? Borrowed and finished. That's all. My work is over. Now you do whatever you want. Statistics. Oh. Which one is not for exam? It's not for examining, for the final exam also. Ah, okay. Share your portions on WhatsApp, because even if you tell me now in the class, I can't remember all this. I'll save it. You share it on WhatsApp, I'll save it. Oh, chain meaning it will be in August also. It may be postponed, not advanced. Okay, fine. Cross multiply. Cross multiply. No? Yeah. 0 into 4 is 0. என்ன சஹானா இது ஜாலியா இருக்கு. உங்களுக்கு இந்த மண்டையா? ஆமா ஆமா. சாரி. Oh. No, I don't understand. What in school? Yeah. Yeah, you told me, no? Euclid's geometry, linear equations, and if you want, I'll share last year's recordings on coordinates. I'll see if I have. Monday is your test, huh? Yeah, is it over? So similar again, we have two cases, x minus 2 and x minus half. They are given factors of, I've called it f of x here. So this is the dividend. This is the dividend. I've called it f of x. And it has two factors. X minus 2 is one factor. So equate it to 0. And we get x is equal to 2. The procedure is the same everywhere. So then you'll have to find f of 2. But what's the value of f of 2? It's 0. Why? Because it's a factor. X minus 2 is a factor. So the remainder will be 0. Then how will you find f of 2? In f of x, wherever there is x, put 2. And you get this equation. 4p plus r is equal to minus 10. Okay. Then same thing here. So in f of x, wherever there is x, put half. 1 by 2 into 1 by 2 is 1 by 4. 5 into half is 5 by 2 plus r is equal to 0. LCM. LCM is 4. 4 into 1. So p into 1 is p. 2 into 2 is 4. So 5 into 2 is 10. And here there's 1. 1 into 4 is 4. LCM is 4. No. 1 into 4. I'm sorry, r into 4. LCM, children. Here we go wrong. LCM we go wrong sometimes. 5 by 2 plus r by 1 it is. R by 1. Common denominator is 4. This is 4. So into 1 into 1. This is 2. How will you make it 4? Into 2. 2 into 2 is 4. So into 2 here. This is 1. How will you make this 4? Into 4. So p plus 10 plus 4r is equal to 0. Cross multiply. So 0 into 4 is 0. So you get p plus 10 plus 4r is equal to 0. Taking the number to the other side. Taking the number to the other side, you get p plus 4r is equal to minus 10. All right. Now you can show two things from this. Depending. Now you will ask me, how do you know that you should subtract or add? You add, you will get a different result. So you have to subtract. If you don't get the desired result, see, you can do only two things. You have two equations, right? You have two equations. You can do two things. You can add or subtract them. On adding, if you don't get the result, subtract it. That's all. Both the conditions are true. Both the conditions are true. This one is also true. This is also correct. This is not wrong. But they're not asking you to show this result. They're asking you to show that p is equal to r. See, I'm saying that when you have two equations, you can either add them or subtract them. You will get a result when you add. You will get a different result when you subtract. Now, what have they asked you to show? Show that p is equal to r. That means it's okay if you get p minus r is equal to 0 also. Then when you take this to the other side, you will get p is equal to r. So that you can get only when subtracting, not while adding, because that's what I've written note here. What is this note I've written? When you add, this is the result you get. So if they ask you to prove that p plus r is equal to minus 4, you should add. Instead of this, if they ask you to show that p plus r is equal to minus 4, show that p plus r is equal to minus 4, then you should not do this subtracting. You must do this adding. Not following? Correct, children? Adding meaning I have not changed the signs. So when you add the two equations, you will get a different result. That's correct. This result is correct. But then if they ask you to prove that, then this is the method. But here you'll have to show that p is equal to r. So if you don't get it like this, then you have to do this. So I've subtracted minus and plus. 4p minus p, 3p. Plus r minus 4r, minus 3r. Minus 10 plus 10, 0. So 3 common, p minus r is equal to 0. This 3 comes for division, 0 by 3, so 0. So p minus r is equal to 0. When you take r to the other side, p is equal to r. So this is what we have to prove. So this note is just for you to understand what will happen if you add. Instead of subtracting, if you add, what is the result you will get? So when you add, you get 5p plus 5r is equal to minus 20. 5 is common. P plus r is equal to minus 20. So p plus r is equal to minus 20 by 5. P plus r is equal to minus 4. These are the correct. This is both are correct. But we have done this because we have to prove this one. All right. One, not all this. Yeah, this one. This is the next one. 1 second. Yeah. This is the next one. Very, very simple, but very important. This is the next one, children. Done, children? Okay. So yes, you tell me. Close your book. Yeah. Yeah, look, other line one, அடுத்த line. Prove that அப்படின்னா you should take up only the LHS, right? So take up the LHS. What is LHS? 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. Yeah, இதுக்கப்புறம் என்ன? யோசிக்கூடாது. Sabarna, close your book. All of you close your book. Yeah, louder, yes. Louder, yeah, faster, louder. Okay. Okay. Plus மறுபடியும் சி ஸ்கொயரா? ரெண்டு பி ஸ்கொயர் எழுதியாச்சு, ரெண்டு சி ஸ்கொயர் எழுதியாச்சு. பிளஸ் ஏ ஸ்கொயர். வெரி குட், வெரி குட். நெக்ஸ்ட். Very good. Okay, I'll tell you. Yeah. இப்போ இந்த மூணு டேர்ம் சேர்ந்தா என்ன? What is a square minus 2ab plus b square? A minus b the whole square. A minus b the whole square. Plus, what is b square minus 2bc plus c square? b minus c the whole square. b minus c the whole square. And what is c square minus 2ca plus a square? C minus a the whole square. C minus a the whole square. That's what it is. So we should write 2a square as a square plus a square. 2b square as b square plus b square. 2c square as c square plus c square. All right. Yes, you have a doubt, Sahana? Then you'll have to group accordingly. See, I'll tell you how to write this step. How to write this step, I'll tell you. First is you should write 2a square as a square plus a square. 2b square as b square plus b square, and 2c square as c square plus c square. After that, write the middle terms. Write the middle terms minus 2ab. See, you should write something here, minus 2ab and something here. Then you should write something here, minus 2bc and something here. Because every middle term will have one term this side and one term this side, right? Like if it's minus 2ab, it'll be like a square here and b square here. A square minus 2ab plus b square. This middle term will have two square terms. So I'm writing the middle terms. I'm writing the middle terms. Now, if it is minus 2ab, I should take up a square plus b square here, because then only it will be minus 2ab in the middle. Then if it is minus 2bc here, I must take one b square term and one c square term. Then only the middle term will be minus 2bc. And then if it is CA here, I must take one C square term and A square term plus C square plus A square. Then only I'll get the middle term as minus 2CA. So like this, we've made use of rend A square, rend B square, and rend C square. And then minus 2AB, minus 2BC, and minus 2C. All right. So with minus 2AB, you should take one A square and one B square. With minus 2BC, BC, no, so B square and C square. CA, so C square and A square. Then these three become A minus B the whole square. These three become B minus C the whole square. And these three become C minus A the whole square. That's the result. Okay. Online students. Finish writing, online students.
Yes, miss.
Okay. It's okay if you don't put the bracket also. If you're getting confused because of the bracket, it's okay. Bracket போடலனாலும் correct தான். Both are fine. Even if you don't put the bracket, then it will be these three terms, and these three terms like this. Right? Yeah. What louder?
The second out.
Yeah, you can multiply. No, when you have an equation, you can multiply both the sides by the same number. You're not changing the equation. Like if you have A is equal to B, you can multiply both the sides by 2. And then you will get 2A is equal to 2B. You can also divide both the sides by 2. So you'll get A by 2 is equal to B by 2. When you have two equations, you can add the same thing to both the sides, subtract the same thing from both the sides. You can multiply the same things to both the sides or divide both the sides by the same number. You can do any operation, but you should do it on both the sides. So I'm multiplying both the sides by 2. So you should notice that when you multiply both the sides by 2, it becomes this question. It becomes this question. That's all. So these two are the same. See here. See here. Okay, you work. It's a earlier situation. Finished. So write out whatever is given here. It's an equation. Here, what you have is an equation. See it? If this one is equal to 0, so this is an equation. You can work this one, meaning you can take this whole thing. If this one is equal to 0, that means this condition is given already to you. You don't have to prove this. With this one given, you should prove that A is equal to B is equal to C. So take down whatever is given. So this one is equal to 0. Take it down. And now work with this one. So to start with, we multiply both the sides by 2. So that gives you 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca is equal to 2 into 0 is 0. Now, this we already know how to work this ahead. You split this as a square plus a square. This one as b square plus b square, c square plus c square. And then you know these steps, correct? Till here you know. Now, what do you understand from this? A minus b the whole square plus b minus c the whole square plus c minus a the whole square is equal to 0. Now, you should understand that a minus b the whole square is positive because anything squared is positive. Anything if you square it's positive. See, even if it's a negative 3, minus 3, if you square it, it's positive. So a minus b the whole square is positive, or it can be 0. See, a minus b the whole square, there are only two cases that can happen. A minus b the whole square, okay, there are three options. A minus b the whole square can be negative, positive, or 0. A minus b the whole square can be negative, positive, or 0. But negative is not possible. Why? Because it is a minus b the whole square. So even if a minus b is negative, when you square it becomes positive. So that means we are narrowing down the options. A minus b the whole square, so it cannot be negative. So it can be positive or it can be 0. Can be positive or 0. Okay. Similarly, b minus c the whole square. It can be 0 or anything positive. That is, it can be 0 or anything greater than 0. It cannot be negative. Similarly, c minus a the whole square cannot be negative because it's whole square. So it will be positive or it can be 0. Can be 0 or positive, it cannot be negative. So all the three can either be positive or 0. No, but it's given that their sum is 0. Their sum is 0. Supposing they're all positive, like positive 4, positive 5, and positive 0. How will the sum be 0? The sum can be 0 only if everything is 0. When will the sum be 0? Only when a minus b the whole square is 0, b minus c the whole square is 0, and c minus a the whole square is 0. Then only 0 plus 0 plus 0 is 0. Supposing it's positive, it can be positive, but if it's positive in this case, like supposing it's 9 here, some 16 here and 0 here, the total will not be 0. The total is something else. So that means this has to be 0, this has to be 0, this has to be 0. So if a minus b the whole square is equal to 0, that means a minus b is equal to the square root of 0. So a minus b is equal to 0 or a is equal to b. A minus b. Take the b to the other side. A is equal to b. Similarly, b minus c the whole square has to be 0. So b minus c is equal to square root of 0, which is 0. So if you take c to the other side, it will be b is equal to c. C minus a the whole square is equal to 0. So c minus a is equal to 0. C is equal to a when you take minus a to the other side. So you get a is equal to b is equal to c is equal to a. A is equal to b is equal to c is equal to a. That means a, b, c all are equal. Proved. See, I'm sure all of you understood till here because it's similar to the earlier one. At this point only, from this point, have you finished writing? From this point, you need to understand from here. I'm repeating the value of all these three, a minus b the whole square, b minus c the whole square, c minus a the whole square, the value for all these three cannot be negative. Because it's whole square, so it has to be positive. It has to be positive or 0. Now, supposing all these are some positive values, how will the sum be 0? See here, how will the sum be 0? You cannot get sum 0 where everything is positive. Something like 9, 16, 100. How will the sum be 0? So they cannot be positive. They have to be 0 only. Only when this is 0. Only when this is 0, this is 0, and this is 0. 0 plus 0 plus 0 will be 0. Will be equal to 0. That means a minus b the whole square should be 0. So a minus b is equal to square root of 0. So a minus b is equal to 0. Because if a minus b the whole square is 0, a minus b is equal to square root of 0, which is 0. So if a minus b is 0, when you take this here, a is equal to b. Similarly, you get b is equal to c and c is equal to a. So that means all the three are equal. All right. This is similar. I'll share this with you. Do this one. There's also an NCRT. This is also an NCRT. Last exercise somewhere. Yeah, children. So in this one, you can see, prove that this one is equal to, so you'll have to take up the LHS. You'll have to prove that this LHS is equal to this. That means you'll have to only take up this part, work this one and get this as the answer. Correct? Because prove that this one is equal to this one. So in such cases, here this equation is true. This equation is true. That means this one is equal to 0 is given to you. You don't have to prove it. What happened? Sorry? Yeah, that's what. It's a different question. Yeah, in this question, this one is an equation which is true. Here you don't have to prove that this one is equal to 0. This is true. But in this one, you'll have to prove that this left-hand side is equal to this one. That means you should take up the LHS, work this one, and the answer you get should be this one. Okay. Okay. So when you look at the RHS, you can see some half. You can see some half here, no? So keep that in mind. Now take up the LHS. A cubed plus B cubed plus C cubed minus 3ABC. Now we know the identity, so let's use that. So this one is equal to A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. That's the identity. So in the next step, we completed A cube plus B cube plus C cube minus 3ABC. That can also be written as, that's also equal to A plus B plus C into A square plus B square plus C square minus AB minus B minus BC minus CA. Children, see, if you have A square minus 2AB plus B square, in the next step, what will you write is equal to A minus B the whole square. Supposing you have A minus B the whole square in one step. In the next step, you can write A square minus 2AB plus B square. Same thing here. You know this identity. So this one is nothing but A plus B plus C into this is the identity. So that's what you write in the next line. Now look at this. You have half here. So what you do, you multiply. Like what is half into 2? What is half into 2? 1. So when you're one in an expression, if you're doing this half into 2, that means you're just multiplying by 1. You're just multiplying by 1. You're not changing the value. See, you can do anything as long as you don't change the value of the expression or you don't change the value of the equation. If it's an equation on both the sides, you must add the same thing or subtract the same thing on both the sides. If you add 4 to the LHS, you should add 4 to the RHS also. If it's an equation. If you divide the LHS by 4, you should also divide the RHS by 4. In an expression, this one is an expression. In this expression, if you want to multiply, if you want to do something, you can do as long as you don't change the value. So when you multiply it by 1, you're not changing the value. So you're actually multiplying by 1. See here, you have written, this is, see children, let me just call this as P, okay? Let me call this as P and this one as Q, okay? All right, so it's like P into Q, right? So what I'm doing is half into P into 2 into Q. I'll tell you once again, see here. This whole thing, no, I'll just call this whole thing P. I'll just call this whole thing P. I'll call this whole thing as Q. So what do you have here? P into Q. You have P into Q, right? Okay, we have P into Q. What we're doing is in the next step, half into P. How can you do that? You can't simply multiply by half. Into 2 into Q. So 2 and 2 will get cancelled. So what do you get? PQ only it is. Still PQ only. That's what we have done in the next step. That's what we have done. We have taken half. See, there's a product. It's multiplication. So we've taken half into A plus B plus C into 2. Into this one. So see here, 2 and 2 will get cancelled actually. So you have not done anything. No change. Well, if you understand this part, then only I can proceed. I've written this one here and this one here. It's multiplication everywhere. I have multiplied this one by half and this one by 2. Okay. Okay. So then now I've achieved this part. I've got this one. I've got this one here. So I'm not going to disturb this. This one I'll not disturb at any cost. I'll keep writing there because I've already got it. No, I'll not disturb that. That'll come as it is. Now this part, we have to work on this part. This part should become this one, which we've already done earlier because we've already worked this earlier. No, this one, we've already worked here. See here, the sum. See this one. This one only it is. Same steps will show there. These steps only you've showed. See. See here, you're writing 2a square as a square plus a square. 2b square as b square plus b square. 2c square as c square plus c square. Then all these three terms. Then you're arranging minus 2ab minus 2bc minus 2ca. Then you're taking a square b square for this. B square c square for this. C square a square for this. That's a minus b the whole square. B minus c the whole square. C minus a the whole square. Which is the RHS. Very, very simple. But you should remember, meaning you should remember all this like a story. This question, like if you have to prove this, it's an identity actually. If you have to prove this identity, you should just make a short story like this and remember that. So the story is nothing. You just have to take up the LHS. Then using the identity, we write the step. And then here in the RHS, we have half into a plus b plus c. So in the next step, we have a plus b plus c. We have a plus b plus c, but we need half. So you write half into a plus b plus c, but you also know that you cannot do that. So to the next part, you multiply 2. That's all. If you do this, then you're not going to disturb this part because you got it. No, you'll not disturb this. You'll keep writing that. Now here you'll work. You'll multiply 2 with every term inside the bracket, 2. With everybody inside, you'll multiply 2. And that's how you get all these terms. Then you'll write 2a square as a square plus a square like that. Then the step. That's all. All the children? Online students? Understood? Yeah. Then do this one. Is it visible? Yeah. Standard questions. Important and standard questions. Children, since we have only 5 minutes left, I'll just start explaining this one. Stop writing and listen to me. So there's nothing much in this. This one is like x cubed. This whole thing is x. This whole thing is x cubed. Plus, this is y cubed. This is z cubed. So what is x? X is a plus b. What is y? B plus c. And what is z? C plus a. Because you have it here. This is x cubed plus this is y cubed plus z cubed, correct? So x is a plus b, y is b plus c, and z is c plus a. Okay, after that, what do you have? And then you have 3 x, y, z. So what the given expression is of the form x cube plus y cube plus z cube minus 3x, y, z, where x, y, and z are a plus b, b plus c, and c plus a respectively. So it's already in that form. So what's the identity? What's the answer? It's a plus b plus c, or x plus y plus z. So x plus y plus z. So what is x plus y plus z? X, a plus b, plus y, see it, x plus y plus z. Okay, so this is x plus y plus z into x square, a plus b the whole square, plus y square, plus z square. Then minus xy, minus x into y. See, this is x, this is y. Minus yz, yz, minus zx or xz. Any order, you can write zx or xz, whatever order. So we're just substituting using the identity. X means a plus b, y means b plus c, z means c plus a. That's all. Once you substitute, that's all. It's over. Now you just have to simplify. So here it is a plus b plus b plus c plus c plus a. Open the bracket. So you'll get a plus a is 2a, b plus b is 2b, c plus c is 2c. Because the addition, no? It's addition. It's not multiplication. It's a plus b plus b plus c plus c plus a. Addition. So a and a is 2a, b and b is 2b, c and c is 2c. That's the first bracket. It's over. All right. Now in the second one, you'll have to expand this. You all know what is a plus b the whole square, b plus c the whole square, c plus a the whole square. All of you know, right? All that. Then how will you multiply? I'll just show you one multiplication. How to multiply a plus b into b plus c. So you should write. You should multiply a into b, ab, a into c, ac plus ac, b into b plus b square, b into c plus bc. So a into b. So this minus sign I've not disturbed. This minus is outside. Multiply with brackets a into b, ab plus a into c, ac, b into b, b square, b into c, bc. Same thing here. Minus we are not multiplying. Only the terms inside the bracket. B into c, bc, b into a, ba, c into c, c square, c into a, c. Then this minus as it is, c into a, ca or ab, ca or ac, whatever, c into b, cb or bc, a into a into b. That's all. Now open the brackets. Now open the bracket. And always, whenever there's something common, we take it out. Whenever there's something common, we take it out. So 2 is common, so bring it out. 2 common. So in the bracket, you'll have 2 of a plus b plus c. 2 of a plus b plus c. Correct? In the bracket. Now everything, we've removed the brackets. Now there's only addition, subtraction here. All this only addition, subtraction here. So after the step, now I have not removed the bracket. I just added it straight away. Anyways, this is plus in the middle. So signs will not change. When the connecting sign is minus, then the signs will change. When the connecting sign is minus, when between two brackets, you have a minus sign. Then after the minus and the term, meaning after the minus sign, the terms in the bracket, you'll have to change their signs, right? If it's minus, if it's plus, no change. So I've added straight away. A square plus A square, 2A square. B square plus B square, 2B square. And C square plus C square, 2C square. Then this 2AB, 2BC, 2C. All right. So this one, as it is, I added and wrote the results. A square plus A square, 2A square. B square plus B square, 2B square. And then this one, 2C square, 2AB, 2BC, 2CA. That's what is here. Here, because there's minus, no, I have not done like, meaning I have not done AB like that. Because it's minus, so we have to remove the brackets. So here it will be minus AB, minus AC, minus B square, minus BC. Then minus BC, minus BA, minus C square, minus CA. When you open the bracket, minus CB, minus A square, minus AC. So that's what you see here. We've opened the bracket, so all the positive terms have become negative. All the positive terms, no, they all became negative. Now you should just simplify. What are the like terms here? There's 2A square. Then look out for A square terms. 2A square, 2A square. Then minus A square. 2A square minus A square is A square. 2A square minus A square is A square. 2B square minus B square is B square. 2C square minus C square is plus C square. Then there's minus AB here, minus AB here, and minus AB here. Minus 3AB you have. See, I'm showing you. Minus AB, minus AB. BA is AB and minus AB. So minus 3AB we have. Minus 3AB plus 2AB minus AB. See, I'm underlining that. This one, AB, AB, AB. Minus 3AB plus 2AB. So minus AB. Then this is plus 2BC, no? Minus BC, minus BC, minus BC. So it will be minus 3BC plus 2BC. So minus BC. Then minus AC, minus AC, minus AC. Minus 3AC and this one. Minus 3AC and plus 2AC. Yes, minus AC. So then these other terms we already took. See here. Where's that A square gone? Minus A square. 2A square minus A square is A square. 2B square minus B square. 2C square and this one minus A square. See, we have taken all the terms. All the terms we've taken. That's all. So there's nothing but 2 into A plus B plus C. So there's nothing but this one is nothing but 2 into A plus B plus C into A square plus B square plus C square minus AB minus BC minus C. The factors of when you factorize this one, you get 2 into A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA. Now, what is this further actually? What is this one? A cube plus B cube plus C cube minus 3ABC. Should not write that because the heading is factorize. So keep it as factors. Don't multiply. Keep it as factors. So keep it as 2 into A plus B plus C into. Don't write A plus B plus C into A square plus B square plus C square minus AB minus BC minus CA if anything else. Don't do anything else. Keep it as it is. Because you want factors, factorize. So this is a factor, this is a factor, this is a factor. Do we have time to write now, children? No. Okay, I'll send the picture. Please complete it. All right. Oh, I'll show the presentation. If you want to complete it, you can complete it. But I'll also share it. If parents are waiting down, you can leave children. Online students, take a screenshot and complete this. Students who want to write can stay back and write. I will be here till you finish. Yeah, but you can leave because your parents must be waiting down. Online students, please respond. Yeah. Please take a screenshot and complete this one. All right?
Okay.
Yes.
All right, children. So that's it for today's session. Thank you so much. Online students can leave the call. Good night.
Thank you.
Yeah. Thank you, children.
Out of 40, I got 35 minutes. Ma'am.
Yes, Swati.